So if we take some examples, we can understand better way. CO NH3 taken 6 times plus 3, right. So first of all, you have to calculate the oxidation number. You have to calculate the oxidation number. What is the oxidation number? NH3 is the neutral ligand, right. So X plus 0, that is equal to plus 3. So what is the cobalt oxidation state? Oxidation number, cobalt oxidation number is plus 3, right. So what is the cobalt oxidation, cobalt electronic configuration? Cobalt 27, right. So it is argon 3d7 4s2, 3d7 4s2, right. So cobalt plus 3, 3d7 4s2, cobalt plus 3, that becomes argon 3d6 4s0, 4d7. So what is the 1 2 3 4 5, 1 2 3 4 5 6 7, and this one is 4s2, right. So this is belongs to this one, this is belongs to this one, right. So 3d6 4s0. What is 3d6 4s0? 1 2 3 4 5, 1 2 3 4 5 6, right. So 4s0. This 4 containing p orbitals, 4p, empty 4p orbitals, 4p orbitals. This one is 4s, this is 3d6, right. 3d6 4s0, 4s0, 4p0, 4d0, 4d0, right, 4d0. So what you have to understand is NH3, in the presence of NH3, electron pairing takes place. Electron pairing takes place. Cobalt plus 3 means you have to remove the 3 electrons from the original one, 2 electrons from the s orbital, 1 electron from the d orbital. So that gives the 3d6. That gives the 3d6. So NH3, in the presence of NH3, electron pairing takes place. Electron pairing takes place. That means electron pairing takes place. That means 1 2 3 4 5, right. So for electron pairing takes place, these 2 electrons come into these orbitals, 1 2 3 4 5 6, total 6 electrons. So pairing takes place. How many vacant orbitals are there? 2 vacant orbitals, and 4s orbital and 4p orbital. Sorry, 4p orbital contains 3 orbitals, so 4p orbital. 4d, it is empty orbital, no need to involve in the. So how many empty orbitals here? 1 2 3 4 5 6. These undergoes hybridization. These undergoes hybridization. These are mixed with these 1 2 3 4 5 6 empty orbitals undergoes hybridization to give 6 hybrid orbitals. To give how many hybrid orbitals? 6 hybrid orbitals. That is, I am writing. So I am writing here 6 hybrid orbitals together. 6 hybrid orbitals together. 1 2 3 4 5 6. So how many empty orbitals are involving? 6 empty orbitals are involving. That's why this is a dsp3 hybridization. So this empty, how many 6 empty orbitals are taking the electrons from NH3? How many NH3s? 6 NH3s, NH3, 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 NH3. So these electrons takes the pair of electron. So this one is pair of electron takes place. This gives the pair of electrons. This also gives the pair of electrons to the empty orbital to form the bond, to form the bond, to form the bond, right? To form the bond. Due to space problem, I am writing here, right? So this contains 1, 2, 3, 4, 5, 6, 3 and 6. So I am writing these are donated. These are donated by which one? These electrons are, the cross marks are nothing but electrons. These are donated by, or you can write it as a electrons donated by ammonia, that gives the, what is hybridization? DsP3. So what are the points? What are the points? What is hybridization? Hybridization D2sp3. Right. What is the type of complex? Type of the complex? Inner orbital complex or outer orbital complex? Complex is, D is the, D comes first, that's why it is a inner orbital complex. So what is the geometry? What is the geometry? Geometry is the, if the 6 ligands are utilized, what is the geometry? If the 6 ligands are utilized, generally you call it as octahedron geometry. Octahedron. Octahedral geometry. So whether it is a diamagnetic or paramagnetic, magnetic nature. What is the magnetic nature? What is the magnetic nature? So is there any unpaired electrons? Is there any unpaired electrons? All these electrons are paired. That's why the magnet, there is no unpaired electron, right? It is a diamagnetic, right? So if it is a low spin complex or high spin complex, the unpaired electrons are decreasing. So before hybridization, the unpaired electrons are 4. After hybridization, these electrons are pairing takes place. Number of unpaired electrons are decreased. So the complex is which one? Low spin complex. The complex is low spin complex, right? Once again, cobalt surrounded by 6 ammonia atoms. Cobalt oxidation number is +3, right? So cobalt electronic configuration, cobalt +3, 2 electrons, it loses 2 electrons from s orbital, 1 electron from d orbital, that gives the 3d6 4s0, right? So these are the 3d6 in the presence of ammonia, right? Here you can write it as a, in the presence of ammonia, in the presence of ammonia, electron pairing takes place. This one, in the presence of ammonia, electron pairing takes place. So how many empty orbitals? So you should understand that the hybridization involves only orbitals, not electrons. Hybridization involves orbitals, right? So these two d orbitals, 1 s orbitals and 3 p orbitals undergoes hybridization. So how many orbitals are undergoing hybridization? 6 orbitals are undergoing hybridization. That gives the 6 hybrid orbitals. That is, these 2 are d orbital, these are 1 s orbital, these are p orbital. That's why it is a dsp3 hybridization. So dsp3 hybridization, this metal is having these orbitals are belong to which one? Cobalt. So once it forms the 6 hybrid orbitals, 6 NH3 molecules donates the electron pairs to these empty orbitals to form the bond with the metal atom, that is cobalt. once it gives the electron pairs, the 6 orbitals are occupied with the 6 pairs of electrons. So what are the points in this one? What is the hybridization? D2sp3. The complex is inner orbital complex because the d orbitals are utilizing n-1 d orbital. 3d orbital is utilizing 4s, 4p is the n orbitals, 3d is the n-1 orbital. n-1, n is the 4, n-1 is the 3, right? So n-1 d orbital is utilizing in the hybridization, that's why it is a inner orbital complex. Geometry, if it is 6 ligands are utilized, the geometry is the octahedron geometry. So after hybridization, all the 4 unpaired electrons before hybridization, after hybridization all electrons are paired, there is no unpaired electrons, that's why it is a diamagnetic, it shows the diamagnetic moment. So the before hybridization it is having the 4 electrons, after hybridization, so all the electrons are paired, so the unpaired electrons are decreased, unpaired, here 4 unpaired electrons, those electrons are decreased, that's why the complex is a low spin complex. We'll take one example, you will understand in the better. So what is the name of this complex? Hexafluoro cobaltate 3. So if the complex is negative, you have to write the cobaltate. So what is the oxidation number? Cobaltate. What is the oxidation number? X. Fluorine is the -1, 6 fluorines, right? Plus 6 into -1, each fluorine is -1 is equal to -3, right? So X minus 6 is equal to -3. So X, what is the cobalt oxidation state? +3. Cobalt oxidation state is +3, right? So cobalt configuration we have already written 27, right? So 3d7, 4s0, 4s2, 4p0, 4d0, right? So what is the cobalt oxidation state? +3. 3d7, so that becomes 3d6, 4s2, 4s0, 4s0, 4p0, 4d0, right? So 3d6, how many electrons? 1 2 3 4 5 6, right? So it is a 1 2 3 4 5 6 electrons, right? 4s0, 4p0, 4d0, 1 2 3 4 5, right? So since the fluorine is which ligand? F minus is electron pairing does not takes place. Electron pairing does not takes place. Electron pairing does not takes place. I told you in the 6th postulate, fluoro, chloro, bromo, iodo, the electron pairing does not takes place. That means the electrons are as such. 3d6 electrons are as such. The 3d electrons are as such, that is 6 electrons. So which orbitals are utilizing in the hybridization? How many ligands are there? 6 ligands. So how many orbitals are required for the 6 ligands? 6 orbitals. So which orbitals are taking part in the hybridization? Right. So 1 s orbital, 3p orbital, 2d orbitals. Why you are taking only 2d? Because already 1 s orbital, 3p orbital, 4 are completed. How many required for fluorine? 6. That's why all these are mixing together to form which one? To form 6 hybrid orbitals. How many hybrid orbitals? 6. 1 2 3 4 5 6, right? 1 2 3 4 5 6. So right, so these are sp3d2. So what is hybridization? sp3d2. You have to understand this point very clearly. Fluorine does not pairing the cobalt electronic configuration because fluorine strength is very low, so the electrons pairing does not takes place. Once it does not takes place, it utilizes the s orbital, p orbital and d orbital. You have to come from the lower to higher. So one s orbital, 3 p orbital, 2 d orbitals. That's why the hybridization is all these mixing together to give how many sp3 hybrid orbitals? 6. This one is the sp3d2. This orbital is sp3d2. It is not related to s orbital, p orbital, d orbital. This one box is related to which one? d2, sp3d2 orbital, sp3d2 orbital, sp3d2 orbital, sp3d2 orbital. This one also sp3d2 orbital. This one also sp3d2 orbital. So 6 sp3d2 orbitals are vacant, 6 sp3d2 orbitals are present. So what is the next one? Next one, it has to donate the fluorine. Fluorine is having the how many electrons? Pairing of electrons. This fluorine is having the pairing of electron. This pair. So how many fluorines are utilizing? 6 fluorines are utilizing. These fluorines give the electrons to vacant orbital. This one, this give the this one. So bond formation requires 2 electrons. It is looks like a coordination bond. It is looks like a coordination bond. I told you in the beginning the NH3 molecule. NH3 molecule. NH3 is having the pair of electrons. The H plus is having the vacant orbital. So it donates the electron pairs to H plus that forms the coordinate covalent bond. In the same way, the fluorines are donating the electron pair to the vacant sp3d2 orbitals of cobalt to form the bond. Once it donates the electron, so that that bond looks like the bond is 1, 2, 3, 4, 5, 6, right? So the electrons are like this. You can write it in the different color, right? So the electrons, pairing of electrons, take each fluorine is giving 2 electrons, right? So this is about cobalt hexafluoro cobaltate 3. Why it is cobaltate? Because complex is negative. Generally you call it as cobaltate. So write the points. What is hybridization? Hybridization is the sp3d2. What is the type of complex? Type of complex, inner orbital or outer orbital. If the d comes first, inner. If the d comes last, it is a outer orbital complex. Outer orbital complex. Outer orbital complex. So it is a diamagnetic or geometry. What is the geometry? If the 6 ligands are utilized, what is the geometry? Octahedral geometry, right? So what is the magnetic moment? What is the magnetic moment? Magnetic moment. How many unpaired electrons? 4 unpaired electrons. 1, 2, 3, 4. So if there is an unpaired electron, you can call it as paramagnetic. Right. It is a low spin or high spin complex. Low spin or high spin complex. What is the type of complex? So the number of unpaired before hybridization, it is a 4. After hybridization also 4. There is no decreasing the number of unpaired electrons. Before hybridization it is a 4. After hybridization also it is a 4 electrons. So the number of unpaired electrons are not decreases. That's why it is a which complex? High spin complex. High spin complex. Once again you have to. So the complex name is hexafluorocobaltate 3. The oxidation state is +3. The cobalt normal configuration is 3d74s2. Cobalt +3. +3 means it loses 3 electrons. So 2 electrons from s orbital. Because why you are losing electrons from s orbital? Because this one is a valency orbital, right? This is a valency orbital. 3d orbitals are inner. First it removes the electron from s orbital, then followed by d orbital. First electrons removed from the valency orbital you have already studied in the periodic table, right? So cobalt plus 3, 3d6, 4s0, 4p0, 4d0. So which are 4s, 4p, 4d, the same shell, valency shell. So fluorine, in the presence of fluorine, electron pairing does not takes place electrons as such in the cobalt plus 3. So these 6 orbitals are involving in the hybridization. Why only 6 orbitals are involving hybridization? Because the number of ligands are 6. That's why the 6 orbitals are involving hybridization. They mix it together to form equal number of sp3d2 orbitals. How many mixing? 6 are mixing. 6 orbitals are same shape, same energy. What are those orbitals? 6 sp3d2 orbitals. These 6 sp3d2 orbitals are empty. So fluorine giving the electron pair to these 3 orbitals. These are fluorine give the electron pair to 6 fluorine atoms give the 6 give the electron pairs to these empty orbital to form the cobalt fluorine bond through coordinate covalent bond, right? So once it donates the electron pair, how it looks like? This is looks like this one. So what is the hybridization? sp3d2. What is the complex? Outer orbital complex. What is the geometry? 6 ligands are utilizing octahedral geometry. What is the magnetic nature? Paramagnetic nature. What is the complex? The number of electrons are not decreasing. The number of electrons are 4. After formation of bonding with ligand also 4. That's why you can call it as high spin complex, right? Hope you understood. With the one is electron pairing takes place, the other one is not electron pairing takes place. By taking 2 examples, nickel tetracarbonyl, right? So tetrachloro nickelate 2, tetracarbonyl nickel 0. What is a cobalt nickel? So nickel oxidation number is here x minus 4 is equal to minus 2, right? So what is the oxidation state of nickel? Nickel plus 2. Nickel plus 2. What is the oxidation? Carbonyl is the neutral ligand. So nickel oxidation state is 0. So this one x plus 0 is equal to 0. So what is the oxidation state? Nickel as such, 0 oxidation state, right? So what is the electronic configuration of nickel? 28. 3d8, 4s2, 4p0. Here nickel plus 2, right? 3d8, 1 2 3 4 5, 3d8. So 1 2 3 4 5 6 7 8. 4s2 plus 2 means the electrons are removed from the s orbital. 3d8 remaining same. This one is 3d8, right? So that one is 4s2 empty orbital, 4p empty orbital. Why you are not taking 4d? Because the number of ligands are only 4, right? So the number of required empty orbital should be 4 only. That's why you are not taking 4d orbitals. So chloro is in the presence of chloro, electron pairing does not takes place. Electron pairing does not takes place. does not takes place. That means 3D electrons or pairing does not takes place. Right. So in this one, which orbitals are involving? One s orbital and 3 p orbitals are involving. So what is hybridization? sp3 hybridization. sp3 hybridization, that gives the how many hybrid orbitals? 1 2 3 4 hybrid orbitals. Right. How many are mixing? One s orbital and 3 p orbitals. That results the 4 sp3 hybrid orbitals. So for this chloride, Cl minus ions, this Cl minus ion or chloro, right? So just you have to write it chloro, right? There is no, right? This chloro or negative, you can write it as a negative chloro. Negative ligands donates the electron pair to this one, Cl minus chloro, right? So once it donates the electron pair, so how the bond formation takes place? So these 4 electrons, that will be 2 electrons, 2 electrons, 2 electrons. These electrons are coming from chloro, right? So this forms the bond with the metal atom. So what is the hybridization? Hybridization is the sp3. Hybridization is the sp3. Right. What is the geometry? Geometry is the tetrahedral geometry. So what is the magnetic moment? Magnetic. So the number of unpaired electrons does not change. How many? Two unpaired electrons. That's why it is a paramagnetic. So the number of complex, there is no inner outer, there is no change, right? D orbitals, you are not taking any d orbitals, right? So it is a low spin or high spin electron spin state. The electrons are as such 3d8 only, so the number of unpaired electrons does not decreasing. Paramagnetic because 2 unpaired electrons. So spin state is high spin because there is no decreasing the unpaired electrons. In the same way, nickel tetracarbonyl, if you see, so the same, but nickel here is 3d8, 4s2, 4p0, right? So it is a zero oxidation state. So zero oxidation state, 1 2 3 4 5, 4s2, 4p0, right? So these are the 1 2 3 4 5 6 7 8. These are the 2 electrons. Right. So these 2 electrons, zero oxidation. So in the presence of carbonyl, electron pairing takes place. Electron pairing takes place. So these electrons come into these 2 orbitals. These electrons, that becomes 1 2 3 4 5. So 1 2 3 4 5 6 7 8, right? So this 9th electron goes like this, this electron goes like this. This becomes 3d10. So this empty orbital, these 3 orbitals utilizing in the bond formation. So this empty orbital, right? So these 3 p orbitals, 1 2 3, so right. Right. So this is a empty orbital, this is a 4 p orbitals, sorry 3 p orbitals. So this utilizes the sp3 orbital. So that gives the 4 sp3 orbitals, 4 sp3 orbitals, 4 sp3 orbitals. These 4 sp3 empty orbitals are fulfilled by the 4 carbonyls. 4 carbonyls donates the electron pairs to these empty orbitals through coordinate covalent bond, right? So carbonyl is a neutral, carbonyl is a neutral, carbonyl is a neutral, carbonyl is a neutral, right? So donates the electron pair. So once it donates the electron pair, what happens? That pair 2 2 2 2, right? So what is the hybridization? Hybridization is sp3. Geometry is the tetrahedron geometry, magnetic moment. So all these two electrons are paired. All these two electrons, s electrons are going into d electrons. These two electrons are going into d orbitals. So one electron is pairing with this one electron pairing with this electron. So s orbital is empty, right? This electron is going towards this one, right? So magnetic, there is no unpaired electrons, that's why diamagnetic. So the number of electrons before hybridization, it is a 2 unpaired electrons. After hybridization, it is a 0 unpaired electron. The number of unpaired electrons are decreased, that's why it is a low spin complex. What is the difference between both two? So one is both are sp3, both are tetrahedral. One is paramagnetic because chloride, in the presence of chloride, electron pairing does not take place, but in the presence of carbonyl, the electron pairing takes place. That's why it is a chlorine nickel complex is a paramagnetic, whereas carbonyl nickel complex is a diamagnetic. So the number of unpaired electron does not decrease. That's why it is a high spin complex. It is a low spin complex because the number of unpaired electrons are 2. After hybridization, the number of unpaired electrons are 0. That's why it is a low spin complex. Okay. Taking one more example, tetracyanoniclate 2. So what is the oxidation number? X minus 4 is equal to minus 2, X is equal to plus 2. What is the oxidation state of nickel? Plus 2. So 3D8, 4S0, 4P0, right? In the presence of cyanide, you have to remember, first one is the oxidation number, second one is in the presence of ligand, whether the electron pairing takes place or not. So in cyanide, in the presence of cyanide, electron pairing takes place. So 3D8, this electron going into this pairing takes place. So one left empty d orbital is there. So this d orbital, 1 s orbital, 3 p orbital, utilizing in the hybridization, that gives the dsp3 hybrid, 4 dsp3 hybrid orbitals. These 4 sp3 hybrid orbitals, cyanide donates the electron pair to these vacant 4 dsp3 hybrid orbitals. These 4 cyanide ions donates the electron pair to 4 empty dsp3 orbital to form the bond with the metal atom. So after forming the metal atom, the electrons are like this. So what is the hybridization? dsp3 geometry is the square planar. Complex is the low spin because before hybridization it is a 2 unpaired electrons. After hybridization there is no unpaired electron. That's why it is a low spin complex. Magnetic moment is the diamagnetic because there is no unpaired electrons. After hybridization there is no unpaired electron. That's why it is a diamagnetic, right? No unpaired electrons. So there are some defects. There are some limitations. It does not give the quantitative interpretation of magnetic data. So it tells about the magnetic data, whether it contains diamagnetic or paramagnetic, but what is the quantity of that magnetic data does not explain. It does not explain the color properties, and also it does not explain the kinetic and thermodynamic stabilities. Right? There are other defects, so these are the enough for limitations. Right? This completes the VBT. So how do, once again briefly, VBT. So in the complexes, first how do you identify the geometry and everything? First of all you have to write the oxidation number, then you have to so whether in the presence of ligand, you have to identify the ligand, whether in that ligand the electron pairing takes place or not. If the pairing takes place, you have to write the pair. If the d orbitals involved, whether it is a inner orbital, n-1 d orbital utilizes inner orbital, if it is n d orbital utilizes outer orbital. The magnetic moment, diamagnetic, paramagnetic, right? So if the unpaired electrons are there, paramagnetic, there is no unpaired electrons, it is a diamagnetic. Low spin, high spin, if the number of unpaired electrons are decreases, you can call it as low spin. If the number of unpaired electrons are not decreases, you can call it as high spin complex, right? So this is about VBT. Okay, thank you. We'll continue in the next class.